Okay, good morning once again, all of you. So today's session, we will be discussing about engineering economics in design. Engineering economics. What is the role of economics in design? So, how to estimate the cost of a particular design and how will economics influence the engineering design? So how do we estimate the cost of a particular design? So we know the techniques of methods or approaches that we can use to design something. Now the thing is that you have designed something. Now it should be manufactured, and finally it should be marketed and it should be sold to customers. Now what is the price that you are going to set for this product? How do you decide the price of a particular product so that the profits of the company improves and also the quality of service that the customers get also improves? So that is the aspect, engineering economics. So how do we decide the cost of a design? Design means design, then we will convert that into final prototype and product, then we will launch the product into market. See, when we buy a mobile phone, it has a price. When we buy an Apple iPhone, it has a set price, and people are willing to pay the price to buy those products. When you want to buy a laptop, different vendors are there. You have Dell, you have HP, you have Lenovo. Each have its own specific features, and it has a set price for each of the product. So how this company people or the manufacturers or the vendors, they decide the product, decide the cost or price of a product, and what are the factors that we need to consider in deciding the price of the product. So that is the economic aspects of a design. So these things we will see in detail today. So designs always have to meet cost related or other economic targets. Always there will be some cost related or economic target. In the sense, when we think of producing a mobile phone, for example, we would have some idea like this would be the size. The cost of the price of the product, and because we are targeting such a section in the society. Sometimes you may be targeting upper class people. Sometimes you may be targeting or middle class. Sometimes you may be targeting on the lower class people. So depending upon the target, depending upon the prospective buyers or consumers for your product, you will set the price. Otherwise it will not work, because if you set a high price for a product and again you are targeting low class people or less affluent people, then there is a chance that it may fail. The product will fail in the market. So the price should match the buying capability of the customers. So we should understand the type of people that we are aiming for, and then we should set. So that is why designs always have cost related or economic targets. Without that, it will not work. Say, for example, a car. There are a lot of car designs, models available for different people with a different capacity of buying, and they can choose their cars accordingly. So it is essential that we understand how to estimate and manage the cost associated with our design work. So it is very much important how to calculate the cost. So cost estimation, how much does this particular design cost? That is a big question that we are addressing. How much does this particular design cost? As a design team, how do we estimate the cost of a design, both as we make it and then over its planned life? So when we make the product, so there will be a lot of components we use, there will be a lot of raw materials we will use. So the cost of all those things, and the cost, and the cost of this product over its planned life. See, planned life in the sense when it is going to reach the market. Right now we are having the design manufacturing. When it will reach the market, maybe after 6 months, maybe after 1 year, we may launch the product. So accordingly there may be some inflation or price depreciation, or so there may be some economic factors which might be affecting. So the situation may not be different. Every time the value of price decreases over a period of time. So 100 rupees today is not worth as the 100 rupees, or 100 rupees after 1 year is not that worth as 100 rupees today. So that is the idea. So in practice, cost estimation is a complex business that requires skill and experience. The simplest way is to estimate the labor, material, materials and overhead cost. No, so for calculating the cost of a product, these are the three factors considered. Labor cost we will consider, material cost we will consider, and overhead cost we will consider. So what are these mean? What we mean by labor cost, what we mean by materials cost, and what we mean by overhead. Some of the terms are seemingly clear, and yet we will try to explore further. So low cost is very likely to be among the objectives of a design artifact. Low cost, yes. Even when money is no object, we will prefer a less expensive solution to a more costly one if both are equal in all other aspects. If we have, say for example, people have a lot of money, and say for example, a person is very rich and he has a lot of money. But even then, if there are two choices, if there are two options available, he will go for the lower price product, even if the products are equal in all other qualities, all other quality of service that the product. If the quality or the features are very similar, then definitely even the rich people also will go for the less costlier one. So that is the idea. So this means that a designer should understand, that is a human psychology. Designer should understand fundamental elements of costing out a design. So labor, materials, and overhead cost. Labor cost, so manpower, include payments to the employees who build the design. So obviously in a company, people will be working, so we need to pay them, as well as to support personnel who perform necessary but often invisible tasks such as taking and filling orders. There will be people who takes your order, there will be people who fills your order and package, there will be people who package your product, package your orders and shipping the orders. So we need to, as a company, we need to pay the salary to all these people. So I need to pay salary to, if I am the company owner, I need to pay salary to all these people. So accordingly, I can set the price of a product. Labor cost also include a variety of indirect costs that are less evident because they are generally not paid directly to employees. What are the indirect costs? These indirect costs are sometimes called fringe benefits. Fringe means not some sort of secondary benefits that include health and life insurance, retirement benefits, employers' contributions to social security, and other mandated payroll taxes. So this such kind of extra money that the company owners pay on behalf of their employees, they are called fringe benefits. So they are indirect benefits or secondary benefits. So in many companies, they are as much as 50% of direct labor payments or wages. In some companies, these indirect payments, indirect benefits are as close to 50% of the direct payments. So we cannot ignore this indirect factors, health insurance, retirements, provident fund, or other stuff. So that is a direct cost and indirect cost. So labor cost include both direct and indirect. Direct means direct salary and other stuff. Indirect means indirect fringe benefits. Now that is one factor. The factor which we considered for the cost estimation of a product is the labor. Second, the factor we are going to consider for setting up the price for a product in the economics of design aspect is materials. So materials include those items and inputs directly used in building the device. What is the material that you're going to use? What are the components that you're going to use? So for example, laptop, mobile phone, or some other machinery, mechanical part. What are the materials? What are the components? Along with intermediate materials and inventories that are consumed in the manufacturing process. Say maybe during the manufacturing process, you might require something, some solvent, some oil, or some other stuff. So cost of everything until the product is manufactured. So that is the material cost. A key tool for estimating the material cost of an artifact is the bill of materials. I think this term is familiar to you because we have discussed in one of the previous classes, bill of materials. I think you remember that. What is bill of materials? Bill of materials is the list of all the parts in our design, including the quantities of each part required for complete assembly. So for example, if you look at the bill of material for a screwdriver, bill of material includes a screwdriver. All of us are familiar with the screwdriver. It has got a handle and it has got a blade, two simple components. So what is the material for making the handle? What is the material for making the blade of the screwdriver? These are the things which will be included in the bill of materials for the screwdriver, and also the quantity also for making one screwdriver, this much quantity is of material is required, and we want to have say thousands lakhs of products, and what is the quantity of the materials required for handle as well as blade of the screwdriver. So that will be the entities present in the bill of materials of for screwdriver. So bill of materials is nothing but the list of all the parts, all the components in our design, including the quantity also. It will also mention quantity, in what quantity we need each one of the component. So bill of material list all the materials used to make the device. It matters greatly whether our design starts with the raw materials or with the materials that have already been worked by our suppliers. So we have seen in previous example, DFA, design for manufacturing, and design for assembly. So same thing is stressed out here. We can either manufacture by using the raw material, or we can assemble our products with parts supplied by the suppliers. In the case of the screwdriver, we might decide to outsource the handle, in which case our bill of material would include a prepared handle rather than a stock piece of cast acrylic. Say for example, if the material cast acrylic is used for preparing the handle, we are outsourcing the making of the screwdriver handle, then we will not include cast acrylic in the bill of material. Instead, what we will include? We will include a prepared handle. We will include a prepared handle in our bill of material, because we already outsource this process of preparing the handle to some other vendors, and they might use cast acrylic, but we don't bother. But we do not include the we do not mention the cast acrylic in our bill of materials. In our bill of materials, it includes prepared handle. Such outsourcing affects the cost of both the materials and the labor needed to transform raw materials to finished products. Material cost can often be reduced significantly by using commercial off-the-shelf materials rather than making our own. If you sometimes parts or individual components may be available in the market for cheap price, but if you try to make those parts, it will be costlier. This is because outside vendors have the machinery and expertise to make very large numbers of parts for a lot of consumers. Say for example, in the last classes we mentioned about nails or screws. They are all available in the market for cheap price. But if you try to prepare or make or manufacture nail or a screwdriver, these are all very minute pieces which are required in assembly of a device or a machine. But we may not have, then we need to set up the equipment for preparing this screw, or then that may be costlier. Sometimes we may require 3 or 4 screws in a part or something like that. Then it may not be worth setting up the machinery to make the screws. Instead, you can purchase it outside for low cost. So that's the idea. So off-the-shelf materials means materials which are available in the market, which are easily available. The cost incurred by a manufacturer. So these two aspects we have covered. First aspect is labor cost. Second aspect is material cost, which include bill of material and other details. Third one is overhead cost. The cost incurred by a manufacturer that cannot be directly assigned to a single product are termed overhead. Say for example, if a company makes a product in a factory that also produces 20 other products, because this is not the only product that the company manufactures. A company may manufacture mobile phone, watches, or computers, laptops, many things it may manufacture. The cost of the building is same, machines are same, sometimes some of the machines are same, janitorial staff, cleaning staff, they are the same, electricity consumed is same. So those things must be shared or distributed among all of the 21 items. So in the manufacturing company, if the 21 items are produced, the cost of the building, machines, they are the same. They need electricity, cleaning staff, janitorial staff, electricity, all must be shared. So that is the overhead cost. Other elements of the overhead cost include the salaries of executives who are to supervise each of the company's activities. There will be people who monitors the company activity. There will be supervisors, as well as the cost needed for accounting, billing, and advertising, isn't it? Accounting, billing, and advertising costs are also in the overhead cost. We need to advertise. We need to have accounting people. Accounts department is same for the company, irrespective of the type of product manufactured. There may be 21 or more products being manufactured, and they are all handled by the same accounts department, same billing department. We need to pay salary for them, and advertising cost also. So these are the other elements of the overhead cost. Cost estimates. Now, how do we estimate the cost? Cost estimates produced during the conceptual stage of a design project are often quite inaccurate when compared with those made for detailed design. So initial stage, sometimes you may not have that much idea. So we may not be able to precisely predict the cost. So sometimes you will have to wait till the detailed design is over. So in heavy construction projects, for example, an accuracy of plus or minus 35% is considered acceptable for initial estimates of cost. So initially you estimate, then a variation, a tolerance of 35% plus or minus 35% is acceptable in some companies. However, this wide range should not be used to justify your casual or careless cost estimation. So, but we should be very careful. Sloppy means careless. So we should not have sloppy or casual cost estimation, but we will make our best of our efforts to calculate the cost. Even then, practically, this kind of variation might happen. That is acceptable. In practice, each engineering discipline has its own approaches to cost estimation. Say, for example, a cost per square inch may be more relevant for certain printed circuit board design. Say, for example, electronics domain, and it is manufacturing printed circuits board. And in that case, the cost may be cost per square inch of the PCB, printed circuit board. Printed circuit board cost per square inch may be a parameter. For example, in computer science, in softwares, cost per line of code. We will calculate the cost per line of code. Say, for example, there are 10 people working on a project, and this project has 10,000 lines of code. And these 10 people are working for 10 days. So I need to calculate it. 10 people, then their salary for 1 day multiplied by 10 days, so total salary. And how many lines of code for this project? 10,000 lines of code. So divide, and you get the code cost of single line of code. So that is also one metric. One approach to calculate the cost in software industry. What is the cost involved in producing a single line of code? So that is cost per line of code. Cost per line of code. So as designers, we should consult with the experienced professionals in the appropriate engineering discipline to estimate the cost successfully, even when we are making only conceptual design stages. If you do not have the experience or expertise, you should consult with experienced people or professionals, experts. Now, another aspect is economies of scale. Do we make it or buy it? So economies of scale is another important factor which determines, which affects, which influences the cost of a particular design. So both labor and materials are subject to economies of scale. That is the idea that we can reduce the unit production cost of a design by making a lot of copies. So that is the meaning of economies of scale. When you prepare thousands or large quantities of a product, you can reduce the cost rather than just making a few originals. Consider the difference between the cost of making one soda bottle in a machine shop and the unit cost to the bottling companies that make millions of cans daily using highly engineered tooling and material. So obviously, for a small machine shop which manufactures one soda can will be costlier compared to a multinational company which produces or which makes millions of cans daily using highly sophisticated mechanisms. So that is economies of scale. When you produce item in large quantities, obviously you can sell the products at a lower price. So high volume production allows companies to distribute the cost of specialized and innovative technologies over a lot of units, thus lowering the cost per unit. Thus lowering the cost per unit produced. That is the idea. Economies of scale influence our design choices in several ways. So first, they require that the designer know the nature and size of the market in which the design will be used. So initially, when we make the design itself, we know this product is going to be manufactured in bulk quantities. So we can use this type of material. We can use that component here, because when you sell the product in large quantities, obviously you will get a lot of profits, and thereby you can increase the revenues. If there are few sales, then production cost must be shared by small number of items, which raises the estimated unit cost. So in that case, you will have to think of which product or which is the technique, which is the design which I should follow, because anyway this product is going to be sold in a fewer quantities. So how do I compensate the expense? How do I get the revenues if I use this material, if I use this design, if I use that design? So economies of scale affect our selection of components that go into our designs. Depending upon the economies of scale, you can select standard components or substandard components. Substandard in the sense, anywhere there is a price target. This product is going to be sold for this particular product. So accordingly, we can select the individual components inside that. Say for example, mobile phone or a computer, which processor I will go for, whether it is i3 processor, whether it is i7 processor or i5 processor, depending upon the price set for this particular item, we can select. And again, for laptop manufacturers and all, they will be sold in large quantities. So definitely you can they can use standard components that are produced and sold in high volumes whenever possible. That is the requirements of the customer side to ensure both lower cost and adequate supplies of replacements. So when you have items in large quantities, definitely spare parts will be easily available. But if the items are sold in lesser quantities, fewer numbers, then the replacement parts will not be easily available. Another term is the cost of the design and the cost of the design device. So what is the difference between these two terms? Cost of design and the cost of the design device. Cost of design. So there is an important distinction between the cost of designing, prototyping, and testing a product and the cost of the product after manufacturing. So cost of design before manufacturing, cost of the design, cost of the device after manufacturing. So consider a new microprocessor. So an Intel, say for example, Intel or AMD is planning to launch a new microprocessor. A company may spend many millions of dollars to design and develop a leading edge chip with the intention that it will initially sell the final products for tens of dollars or eventually for $1 or less. Eventually, I will be able to sell this product for at a very lower price, $1 or a few dollars, hundreds of dollars. But I am right now spending millions of dollars in the research and development for the production. So that's the cost of design. Cost of design, the amount of money that company invests in getting the idea generated, getting the prototype, getting the final innovative product done. So that is the cost of design, and the final cost of the design device is the price at which these products are sold in the market. In other cases, the cost of the design is relatively small part of the final product. In the case of microprocessor or some mobile phones or some technology, there a lot of money might be required in the research and development. Say for example, how to produce or manufacture or make a faster microprocessor. A lot of research has to happen, right? So right now we have a microprocessor with this much speed or this much execution speed. So how will I improve the execution speed of a processor? That is all of a sudden we cannot get the answer. A lot of people need to do a lot of research in that area. So I need to a lot of work then we need to carry out. Sometimes we need to have reverse engineering. So we studied the reverse engineering aspects and all. So in that case, a lot of money is involved. But finally, as a result of this investment, as a result of this research and development, if my company is able to come up with a better design or a better microprocessor that is faster than all of the available microprocessor in the market, then that is a turning point for my company. I can sell, and there will be a lot of people who will be buying my product, and then finally I can sell the product at a lower price. Once the design is ready, only the manufacturing cost, so that may be very less. So I can set the price accordingly, and I can reap a lot of revenues. So, but in some other cases, design here, in the case of microprocessor example, the cost of the design is huge compared to the cost of the final product. Sometimes, in some other example, cost of the design may be a small part of the final product, such as a building. So if you design a building, or if you design a skyscraper, or building a dam or something like that, then on the design is, you need to find an suitable architect, and he will design it. There is not a lot of research or development, something like that, compared to a hardware product. So here the charge we need to pay for the architect. So that when you consider that with the final building cost, so it is very less. So the cost of design and the cost of the designed product will vary depending upon the product. As such, costs are an important element in the profit equation. Revenues, on the other hand, are determined by the price charge for an item multiplied by. So how do we calculate the revenue? Revenue we are determined by the price charged for an item multiplied by the number of items sold. For most profit maximizing firms, prices are not set on the basis of cost, but rather in terms of what the market is willing to pay. If you look at any of the products available in the market, the prices are not set on the basis of cost. Actual cost may not be, maybe a fraction of the price. Say for example, an Apple iPhone. So it may cost you 1 lakh or 2 lakhs, but the actual cost may be very less. But how do they set the cost of the price of the product? Because they know the market is willing to pay this much amount for this particular product. So that is also another aspect which governs economics in design. Consider our leading edge microprocessor. It may command a price of hundreds of dollars when initially introduced. It may command a price of hundreds of dollars. However, the cost of making each chip over the full production run are well below that. The actual cost may be very less. The materials in the chip may cost pennies, very little amount. The labor per chip is essentially negligible because we are producing the microchip in large quantities. So the cost automated through automated process. So the actual manufacturing labor cost per chip may be very less. Even the cost of research and innovative production lines are relatively modest when shared among the many millions of chips ultimately sold. So that is the idea, economies of scale. Many millions of chips are sold, and thereby the price is very less. But since the company anticipates great demand for its new leading edge processor, it will set the price. So company know that because I know everybody are waiting for a faster processor. So if that is the information the company has, then it can set the price accordingly. So everybody is waiting for, say now everybody is waiting for 5G to come into our place, and a lot of developments will come. So a 5G phone, how much the 5G phone will cost? There will be a lot of buyers for 5G phone. So they will set the price accordingly. There are customers willing to pay a premium to get them. Indeed, the responsibilities of marketing professionals on a design team usually include identifying design attributes that make consumers willing to pay a high price for a new product. Otherwise, gaming console, say for example, a new gaming console company wants to launch into the market, and they know that people are waiting for this particular works gaming console. So then accordingly they can set, because the market demand is huge. The people are willing to pay the money. So that is the response to identify such information. That is the responsibility of the marketing professional of the design team. Now, one last aspect of economics of design is the time value of money. So time value of money is, so initially in one of the initial slides we have mentioned that the economics or economics in design includes the cost involved in the manufacturing process, and also the lifespan of the product is considered. So lifespan of the product is considered. What we mean by that? Today we are designing, today we are developing the product, and we are spending money today. So for designing and development, I am paying the salary of my employees today, or this month I am paying the salary, and I am paying for the raw materials today. Currently I am paying as per the current market. I am paying them the money. But when this product will be finally developed, it may take 6 months, it might take 1 year. So only at the end of 1 year, I will be able to launch this product to the market. So at that time, what will be the value of rupee? What will be the value of dollar? So will there be any inflation? Will there be any depreciation in the value of money? So that parameter also should be considered while setting the price of the product. So that is the time value of money. Beyond the immediate cost of making a new design products, we also have to consider the economic consequence of our design choices over the full lifetime of the designed artifact. This is made more difficult because the value of money changes over time. Say for example, if someone were to offer us $100 today or $100 a year from now, so which will you prefer? Somebody will give you $100 today, and he's telling that you have two options. You can either select $100 today, or you can select $100 after 1 year. So most of us would prefer to take the money now, because having the money sooner offers us a number of advantages. We can invest or otherwise use the money. If we get the money right now, we can eliminate the risk that the money might not be available next year, because next year we don't know what will happen next year, and we don't have to worry about inflation that will shrink the purchasing power of the $100 if you wait for another year. So considering all these parameters, it is always better to get the money right now. So simple example highlights an important concept: the time value of money. Money obtained sooner is more valuable than money obtained later. Money $100 obtained today is more valuable than $100 that we will get after a year. But money spent sooner is more costly than money spent later. The $100 spent today is costlier than $100 spent a year later. So that is the time value of money. That is the time value of money. So this also you should be careful about. The time value of money captures the effects of both opportunity cost and risk. So opportunity cost and risk. Opportunity cost means opportunity cost is a measure of how much the deferred money could have earned in the intervening period. Intervening period, say for example, after 1 year. After 1 year, say today I am giving you 100 rupees, $100. After 1 year, I am giving you $100. So opportunity cost is if I defer the receipt of this money, how much could I could have earned if I get the money right now. So that is opportunity cost. So obviously the money received today will be more cost effective than the money we receive after some time. So risk captures the chance that the money will be worth less because of inflation, and that change circumstances could make the money unavailable during the intervening time, because sometimes business may go down. So who knows that? So right now, that is why first to the market, always first to the market. That is a policy adopted by most of the companies. So we should launch the product at the earliest, because right now we know the situation, but after 1 year we cannot predict what will happen in the markets. There may be a competitor company who launches the product before we launch, and then sometimes we may lose the market share. Then how? Then all the investments that we have made in the design development of a particular product, will definitely will go into vain or wastage. So that should not happen. So that is the risk element involved there. So time value of money captures both opportunity and risk. So opportunity cost is a measure how much the deferred money could have earned in the intervening time. If I get the money right today, how much? Or if I get the money at the earliest, what is the benefit for me? That is opportunity cost. Or risk means after if I get the money later. So what is the risk? That money will be worthless and money may be unavailable because of business equations, change of business equations. So economists and financial professionals bundle together the extent of these risk and lost opportunities in a single term called discount rate. So they consider discount rate. So how do we distinguish between $100 today and $100 a year from now? If the annual discount rate is 10%, so what is the discount rate? Discount rate we consider that includes opportunity cost and risk elements. So if the annual discount rate is 10%, then we would expect to need $110 after 1 year. Today, if you give the money today, you can give me $100. But if you plan to give me the money after 1 year, considering the discount rate of 10%, 10% of 100 is 10. So 100 plus 10, you will get 110. So at the end of the 1 year, you will have to pay $110. So in order to compensate us for not having $100 today, or to purchase then what we could purchase today with $100. So value of money changes over time. So inflation or depreciation of money is a reality. So what we can purchase today with $100, we'll be able to purchase only with $110 if we consider the discount rate over a period of 1 year, annual discount rate, which includes the opportunity cost and risk cost. So we would be getting the same value if we expect $100 now or $110 a year from now. So we can write this up more generally. So VF is equal to 1 plus R into VP. So what is VP? What is VF? Future value of money. What is VP? Present value of money. So future value of money, what is the present value of money? 100. So what is the discount rate? R is the discount rate expressed in percent. So present 10% is 0.1. So 1 plus 0.1, 1.1. 1.1 into present 100, so 110. So VF will be 110 at the end of 1 year. So that is the future value of money. So this is the value of money how value of money, how it changes over time. So this is called the time value of money. So I think I have made things clear. So today's class we discussed about the economics in design. So what are the cost elements? So the factors considered in the cost: labor, materials, and overhead cost, and also how economics of scale affects the design choices and the price setting process, and also the change in the value of money over the period of time. So thank you very much. Any doubt if you have, you can ask now.